The textbook we're using also contains certain statistical tools using the F distribution that will not be required topics of this course. However, those readings provide supplemental information you may wish to pursue. These are truly very valuable statistical tools for a number of interesting problems. Statisticians have developed a method called analysis of variance, abbreviated Anova, for hypothesis tests comparing averages across more than two groups. Let's say we want to know if some continuous variable varied across multiple categorical groups. An example would be literacy rates across multiple countries as a concern for economic development policies, or poverty rates across different regions of the United States. The supplemental material covers the simplest form of Anova, called single-factor one-way Anova. The purpose of one-way Anova test is to determine the existence of a statistically significant difference among several group means. The test actually uses variances to help determine if the means are equal or not. The null hypothesis is simply that all the group population means are the same. The alternative hypothesis is that at least one pair of means is different. For example, if there are k groups, the null hypothesis is that the mean of group 1 is equal to the mean of group 2 is equal to the mean of and so on for however many groups there are. This is tested against the hypothesis that any pair of groups has a different mean. This test is conducted by comparing the variance across the groups and the variance within the groups. If the variance across the groups is large relative to variance within the groups, it is concluded that there are significant differences in the means of the groups. Put simply, if the characteristics in each group are tightly clustered, but the groups are different one from each other, then the means of the groups must be different. The supplemental material will also present various facts about the F distribution and a discussion of concerning the F ratio, which is used to test hypotheses using Anova. But we have left you hanging as for my capital investment problem. Which machine should I buy? Which portfolio has the lowest risk? And how are we going to evaluate what goes on in our schools to the betterment of the common weal?